Hello, everyone, and thank you for joining Broadleaf's Microservices Architecture Reveal. This is Brad Buell, the CRO at Broadleaf, and today I'm joined by Jeff Fischer, Broadleaf's CTO, who will be going through the high-level tech detail on today's webinar. Jeff, looking forward to it.
Hello, everyone. Thank you.
Today, I'll briefly discuss Broadleaf's path to microservices and some of the drivers we see at our clients and in the market in general in moving toward a microservice-based architecture, before Jeff digs into our tech stack, reference architecture, and what services look like at the different layers. Broadleaf has been leading custom enterprise commerce solutions for a decade now, with many well-known brands making up over 40 active enterprise clients today. Through each custom commerce solution delivered, the ability for Broadleaf clients to deeply customize each area of the platform needed, while having access to Broadleaf's source, have led to much more rapid development, where Broadleaf clients are truly able to own their own solution, keeping the best of both worlds really, and building their own platforms, leveraging Broadleaf as a base, with 24/7 support and ongoing updates for all of Broadleaf's licensed clients. This culture of solution ownership, high performance, rapid development, and deep customization continues with the introduction that we've got today of Broadleaf's microservice-based platform. Over the past few years, companies like Netflix and Amazon have brought to the forefront a microservice-based architectural pattern, allowing discrete services to be performant and scalable, allowing for a truly agile or iterative upgrade and maintenance path for solutions, which also lead to better performance, troubleshooting, and speed of development. But adding to these benefits in a commerce setting, Broadleaf continues to leverage Java and Spring, adding Spring Boot to the mix, not only re-architecting Broadleaf's application from the ground up using microservice-based patterns, but also re-architecting our administrative console and React, while leveraging the 10 years we have of working with metadata-driven admins to bring what we believe is a best-of-breed solution that can run not only Broadleaf, but also other third-party microservices in a single environment. And across the entire stack, any level, whether the application, administrative console, or deployment options can be customized to meet enterprise-level problems that allow businesses to have a faster time to value in a cloud-agnostic environment. With that, Jeff, I'll let you take it from here as we get into the tech behind the platform.
Okay, thanks, Brad, for the intro. I'm going to start us off with discussing the technology stack for the Broadleaf microservices. Broadleaf microservices are based on Java and Spring, and we make heavy use of the Spring stack across the board. This includes many of the Spring libraries you already know, like Spring Data and Spring Boot. We also leverage Spring's cloud stack to include additional components for gateway and messaging support using Spring Cloud Gateway and Spring Cloud Stream. With our new offering, we continue to support a variety of RDBMS platforms, in addition to new support for NoSQL solutions. You'll see support here for Postgres, MySQL, Maria, Oracle, and Mongo as well. We're also compatible with a number of presentation tier technologies, single-page application technologies, including Vue.js, Angular, and React, are great tools for building custom e-commerce sites against the Broadleaf API. In fact, our admin platform is written entirely in React. More traditional server-side page rendering technologies like Timeleaf also continue to be available and can also be used to interact with our APIs. We have flexible support for a variety of message brokers through Spring Cloud Stream. Our reference implementation leverages Kafka out of the box, but it can be replaced with Google PubSub or Microsoft's and Amazon's offerings in this area. Finally, we have many deployment options for the services exposed by the Broadleaf framework. For example, we deploy Spring Boot executables via Docker and Kubernetes in our reference implementation, and this represents a modern and scalable approach. However, it is entirely possible to deploy these services as more traditional applications in regular web containers. There's a lot of flexibility here. This next slide represents our opinion on a great mixture of technology and deployment options that we think will meet most needs. We think this is a great place to start and represents how we work with and deploy the services here at Broadleaf. We expose a set of APIs that can be consumed by multiple channels, In front, we expose a gateway component that acts primarily as a routing mechanism. The gateway is not a required piece of the architecture, but it does help alleviate challenges related to CORS and cross-origin requests from browsers. Next, we have a tier of services that are responsible for powering the admin experience. This includes Node.js for serving the React application. There's also a metadata service that informs the admin application of the resource services that are available for management, and I'll talk more about that later. Additionally, we have an auth service responsible for authentication and OAuth 2 authorization. Finally, at this tier, we have a menu service that informs the navigation structure of the admin. Next, we have a resource tier that is home to services that fulfill the e-commerce related functionality of the system. Catalog and cart services are a couple examples here. Finally, the majority of communication between services is handled via async message brokers. Many of you will recognize Kafka, and others, including cloud-native offerings, are supported as well. Let's talk specifically about the resource tier. The resource tier services generally serve to cover the use cases related to e-commerce. These range from PIM-related services like catalog service for merchandising products and categories to cart-related services like search and customer profile. We also have cross-cutting concern services that manage aspects across multiple services. This includes sandboxing and tenant services. Any sandbox capable service is capable of persisting sandbox data that is visible only to the editing user. Then there's workflow to promote, review, and eventually schedule the change for deployment. Through the async messaging infrastructure, the sandbox service is able to manage this lifecycle and inform the user from a central location of sandbox state spanning multiple services. In a similar vein, one of the duties of the tenant service is to manage catalogs, which represents groups of data based on one or more partitioning strategies. These groups can be arranged into complex hierarchies with interesting inheritance behavior. Deployments in a top-level catalog can result in propagation through inheriting catalogs all the way down to the catalogs consumed by a storefront, at which point the change is exposed to real customers. Multiple services can have data belonging to shared catalogs, and the tenant service is the central location for management of this information. These services can also be composed in interesting ways. In a granular deployment, each service has its own JVM running in a Docker container. You achieve scale by adding more instances of each service. There's a lot of individual scaling flexibility here, but it can result in a larger infrastructure footprint than you may want, especially for services that are underutilized and don't require an individual footprint. Multiple Broadleaf services can be composed together in a single container, which allows you to optimize your infrastructure outlay for components of the system where your scale needs are not as high. The majority of communication between services is handled with messages via async message brokers. Persistence messages are sent on state changes. When a mutating change is requested via the API, the system not only persists the change, but will also emit a message about the state change to the broker. This message is a great way to integrate with the system and be notified of changes as they occur. In fact, this will often extend beyond Broadleaf-based services, and consumption of these messages will occur in new or existing services seated outside of the Broadleaf ecosystem in the enterprise. Our message emission is also resilient and can handle temporary broker outages. The state is tracked and expected messages will be emitted and acknowledged once the broker has returned to normal function. Finally, our reference implementation uses Kafka, but this can be replaced with other brokers via Spring Cloud Stream configuration. The administrative platform is primarily driven by metadata. Metadata serves to inform the admin of the available resource tier services and describes the fields and visual presentation aspects of the forms rendered in the admin to manage the resource data. In this way, it is the primary vehicle of discovery for the admin application. Resource tier services provide metadata describing themselves in the form of a metadata library jar. Then the metadata service includes these libraries and aggregates the information they contain. The metadata service is then able to serve as a central communication hub for the admin application regarding this information. We also have an auth service responsible for authentication and OAuth 2 authorization. This is a modified version of Spring's OAuth 2 services and allows us to have an out-of-the-box security solution. For those implementations that wish to use a different provider or a third-party provider, this auth service can be swapped out. I'd like to take some time to talk in a little more detail about the anatomy of a Broadleaf microservice. There are a number of components that serve to pass requested information through business logic, then into persistence and message emission. What you see here is a generalization, but the broad strokes remain true for all the microservices we produce. Let's go into some detail about the interactions between each of these components. We start with the communication between the presentation tier and the API. Our APIs are exposed via REST and HTTP. We generally use JSON as the way to describe entities for a RESTful request. We expose a number of basic fetch APIs to cover everyday use cases. We also offer a much more powerful mechanism for ad hoc query via the API in the form of RSQL support. Through RSQL-based syntax as part of the request param, the RSQL fragments are converted into real criteria included in database queries during the fetch. This opens up a lot of additional API fetch power without requiring implementation of new API. We've also added an alternate paging paradigm that allows for stepping forward and backward through large result sets via the API without requiring an additional count query for every page. Those of you familiar with the query demands on paging know that removing the additional count query can be an additional performance lever, and we're happy to present this option as part of the framework. Once the API has received the request, it is passed on to a Spring component for processing. This service component is responsible for executing business logic based on the data, including possibly communicating with other services. It is noteworthy here that the structure of the data at this point is platform agnostic. This means that the service component is unaware of how the data will be persisted and doesn't have any JPA-specific concerns, for example. It is possible that the persisted structure could be different in a number of ways based on the requirements of the backing platform. However, here at the service component layer, it is primarily interested in a universal projected structure of the data. Once the service component is ready to persist the data, it communicates with the mapping pipeline to get a suitable representation ready for persistence in the database. This pipeline phase is also responsible for managing information on the entity related to sandboxing and catalog state. These pieces of information tend to be leveraged as part of the operations initiated by the sandbox and tenant cross-cutting services mentioned earlier. This pipeline is an open architecture, and additional members can be added or tweaked as part of your customizations to mutate out-of-the-box behavior. And finally, once persisted, the service notifies the broker of the state change. We communicate through Spring Cloud Stream for this over a specific channel. Finally, once the service component has achieved a ready-to-save state of the data, it requests persistence via the API exposed on the Spring Data repository. The repository is configured through Spring Data to interact with the backing data store and realize the final state of the data in the database. Customization here continues to be flexible. Repository behavior can be changed or enhanced with custom Spring Data repository fragments that you add. In this way, you can add additional persistence behavior or override what we ship with out of the box. Also, this architecture allows Broadleaf to be interoperable with a large variety of backing database platforms, including a NoSQL option. Broadleaf ships with a repository layer for JPA that covers classic RDBMS platforms. We also ship with a Mongo repository layer provider to cover the MongoDB platform. So in summary, microservice architectures are a great way to deliver incremental value quickly and scale performance where you need to. Broadleaf builds on the microservice architecture to provide a highly customizable set of commerce and management components. We leverage our experience in metadata-driven UI to deliver a developer-driven, unified back-office experience. And the framework is built on the technologies that your developers already know and love.
Great, thank you, Jeff. Again, for anybody that has questions, if you could ask those questions on the control panel of GoToWebinar. We will start the Q&A section now. And we've got a few queued up here. So the first question here is, how does pricing work for Broadleaf's new platform? It's a great question. I'll take this one, Jeff. Given that Broadleaf's pricing in the past has largely been server-based, obviously in a microservices environment, there's a need for larger deployments across infrastructure that might not be used frequently. And so we have what we call business bounds pricing. That includes items like catalog size, orders per year, and number of total admin console users that determine pricing. But that also allows for an unlimited infrastructure deployment within those business bounds. So hopefully that helps, and we're happy to answer any pricing questions that you've got specifically to offline as well. If you want to email info@broadleafcommerce.com, we'll make sure to have a conversation with you separately. Another question is, can the Broadleaf monolith and the microservices be integrated? Jeff, I think this is a good question for you to kick off.
Sure, thanks, Brad. That is a great question. So I will answer that from the standpoint of any monolith application. Broadleaf monolith, our current offering being one of those examples. Most definitely, yes. We anticipate this will be a common pattern and paradigm for migrating incrementally to microservice. It's a pattern that reduces risk and allows you to deliver value more quickly to your customers. So yes, most definitely we see that happening. It really becomes an idea of, where do you want to start? In the monolith, it might be a common use case for folks to decide to bite off of the cart operation services, for example, is a good place to start, and perhaps keep the rest of their functionality in a monolith for the time being. That becomes then a project of targeting, where in the application flow does the integration to the new services need to be made, as the presentation layer interacts with the customer, and then requests to add things to cart take place. Those points in the code will need to be modified to interact with the API instead. So there's, that's a simplified, obviously way to think about it, but definitely we anticipate that it will be a common pattern. We would also, encourage people to, contact us if they have, questions about, their unique case. Broadleaf is definitely built to be a highly customizable framework for microservices. So, we anticipate that, there are going to be hard problems out there that we're going to be helping folks solve. And, we'd love to be able to discuss and help you, get to, a great vision for a design of how you would be able to migrate off of that monolith platform onto something like a Broadleaf microservices in an incremental way.
Yeah, and so it would be, it would be fair to state then, Jeff, that you could also, I see kind of a question here around cherry picking. You could cherry pick kind of the microservices that you want to use and just deploy, say, a pricing microservice within a specific context of your current commerce platform to begin with. Is that correct?
Yes, that's also, a common use case. It may be that you have an existing platform and you're not necessarily interested in entirely replatforming, but maybe you're looking to shift out a portion of your platform. I'll give an example. Broadleaf has a really powerful discounting engine. We call that our offer service, is really where that's housed. This could be a feature that could be compelling for an existing e-commerce implementation where they wanted to offer, advanced discounting mechanisms to their customers, but maybe they didn't want to re-platform their entire e-commerce infrastructure, just, grab the power of that one piece. So yeah, most definitely we anticipate that cherry picking will take place. that people will be looking to utilize, one or more or all of our microservices as the case may be.
And it looks like there's several questions around this kind of theme. And so another one that's kind of tangential to the same question is, can I use some like enterprise catalog services, one example here, instead of the Broadleaf catalog microservice, but still know about, right, that first party, it sounds like, enterprise service that's already built. I know that's something that we regularly look at with like our the monolith platform. I assume that the same thing in the microservice platform, that you only use the sections that you want to use, right?
Correct.
You don't have to leverage the entire infrastructure.
Yes, I think that's an accurate statement for sure.
And then there's an architectural question here. Is there a single database used across all microservices? I don't know if there would be any cases where you'd want to use multiple databases for different microservices, but.
So that's, I think that ends up being part of the composition strategy that I talked about earlier. Utilizing a single database could be an interesting strategy if you wanted to minimize your footprint for one or more services. So that's entirely feasible. The way I could see that happening is, out of a single database, you perhaps have multiple schemas, so you've still got bounded context taking place. You just happen to be solving the problem out of a single, database installation. I think, in most cases, in a traditional microservice case, each cluster of individual microservices would probably have their own database instance. And that's, certainly an approach that we see common as well. So I think really the answer to that is you have options there. But most normally they would not be a shared database between them all, but they could be.
Yeah, and so in the, for example, when we talk about like the customized deployment ability, you could have multiple microservices in the same container, all leveraging the same database instance. Is that correct?
Certainly, yes.
Okay.
That could be a particular deployment option if that was interesting for a user, for sure.
Great. We've just got another minute or two left. Jeff, let's see. I've got several other questions, and again, please do follow up if there's anything that we don't cover with you by emailing info@broadleafcommerce.com. We'd be happy to follow up with any additional questions that we're not able to get to today. Let's go back through here, Jeff. Anything else?
So I see a couple here. Do you use reactive Spring in your microservices? I think in a couple limited circumstances we do, but in general, we are not leveraging that portion of Spring at the moment. I also see Spring Cloud, Netflix Stack, OSS, Ribbonzool, Hystrix. We are actually leveraging, for those of you that are familiar with the Spring Cloud Stack, I've mentioned so far in this webinar Spring Cloud Stream, which is the abstraction for the messaging brokers. But that Spring Cloud stack includes a number of advanced components that are really an evolution on top of or after the Spring Cloud Netflix stack. For example, our Spring Cloud Gateway is an evolution of the initial Netflix Gateway library. So we are tending to not use the Netflix stack specifically, but instead leveraging the Spring Cloud stack as it advances and evolves beyond the initial stuff that Netflix offered. That includes Hystrix as well for our circuit breaking technology. Gosh, the library is escaping me, but we are using the alternate Spring recommended circuit breaker instead of Hystrix right now. So great question. I think we're using just kind of the more evolved versions of those technologies for sure.
Great. Well, that's all we've got time for today. Thank you, everyone, for joining. We are available at info@broadleafcommerce.com if you've got any follow-up questions. We'll look forward to you joining us on November 20th for our admin reveal. Thank you again for your time today. Talk to you soon.